All right, geometry. Our next type of volume we're going to look at is volumes of pyramids and cones. So what is a pyramid and a cone? Well, a pyramid is a polyhedron. It has one base. So it has one base. And then the other lateral faces are going to be triangles. Okay. And they do meet at a common vertex called the vertex of the pyramid, which is this top point. Okay. So that is why the lateral faces are triangles, because they do meet at that top point. Now, the other important thing is the height. Now, unlike prisms, the height of a pyramid is usually inside the pyramid. So it goes from that top vertex perpendicularly down to the base. So they call it the altitude, but that's also the height. Okay, so that dotted segment going down through. Okay. We will talk about the slant height honors geometry when we talk about surface area in the other videos. Regular geometry, no worries. Okay, so then, just like a pyramid, you have a cone. A cone is the circular version of a pyramid. So its one base is a circle, and again, it has that vertex up top. Again, the altitude or the height goes right down in the middle. Remember that in this class, we're very focused on these circular 3D shapes. Okay, so let's talk about the volume of a pyramid and the volume of a cone. So for a pyramid, it's going to be 1/3 the area of the base times the height. So again, remember that that B is the area of the base. So typically we'll deal with squares. So if your base is a square, so if the base is a square, you could think of it as base times height, or you could think of it as the side length squared. Whatever you want to do, doesn't matter. The base and height will just be the same. Okay. So again, that would go there, and that gives you your 2 dimensions, and then the height. And again, the height is in the pyramid. The height is going to be your 3rd dimension. And notice you take 1/3 because a pyramid is actually 1/3 of its prism. Its matching prism. For a cone, again, it's the same formula, 1/3 area of the base times the height, as you can see, but because the base is a circle, they do throw in the pi r squared in place of the capital B. All right, so there we go. All right, nice. So I'm going to go to Delta Math and do a couple problems there. So follow along. All right, so let's take a look at this problem here. It says find the volume of a pyramid with a square base where the perimeter of the base is 15.8 feet and the height of the pyramid is 20.4 feet. Round your answer to the nearest tenth of a cubic foot. So again, if you can visualize this square pyramid, right? So here's my square base. Here's my vertex. I draw it down, down, down. There we go, right? So there's my square pyramid. Now, they tell me that the perimeter of the base, the perimeter is 15.8. Well, since this is a square, all 4 sides are the same. So if the perimeter is the addition of all 4 sides, to find the length of one side, call it S, we're going to take that 15.8 and divide it by 4. This will give me the length of one side of that square base. And I got 3.95. So that's going to be the length of each side, 3.95. And then they tell us the height is 20.4. So that's the height going straight down to the middle. That height is 20.4. So I'll use the formula for the volume of a pyramid. Volume equals 1/3 the area of the base times the height. In this case, the base is a square. So again, you can do 3.95 times 3.95, or you can do 3.95 squared. So 1/3 the side squared times the height. So that's going to be 1/3 times 3.95, missing that, there you go, squared, times the height, which is 20.4. And that's what I'm going to type into Desmos graphing calculator. 1/3 times 3.95 squared times 20.4. Let's see if I can remember that. So I'll come right here. So it was 1/3 times 3.95 squared times 20.4. I got 106.097. The problem says round to the nearest tenth. So if I round that to the nearest tenth, the 9 rounds the 0 up to a 1. 106.1, and that would be whatever the units are cubed. 106.1 feet cubed. 106.1 feet cubed. There we go. Great. Okay, let's do one more from here. All right, so this time it says find the volume of a right circular cone that has a height of 12.5 centimeters and a base with circumference of 5.8 centimeters. Round your answer to the nearest tenth of a cubic centimeter. So here's my cone. It has a circular base, and then it has its top vertex, and there we go. So for this one, they give me the circumference of the cone's base is 5.8 centimeters, and the height of this cone is 12.5. Now again, we need to know the radius of this cone because we have to find its area, right? Volume equals 1/3 the area of the base times the height. And again, because the base is a circle, the capital B is pi r squared, and then the h just follows, right? So we need the radius. So we're going to use the circumference to find the radius. I'll do it right here. So circumference equals 2 pi r. So your circumference is 5.8 equals 2 pi r. To get r by itself, you must divide by 2 pi. Remember, if you're using a dinky calculator, put that in parentheses like me. So 5.8 divided by 2 pi in parentheses is going to be 0.92. And again, I'm not going to round for a long time. 0.9230. We're going to go 99, something like that. Okay? So that's my radius. So now when I find my volume, it's going to be 1/3 pi times that number. And again, I'm going to type it all in squared times my height, which is 12.5. Okay? So let me go to the graphing calculator and let's do this together. 1/3 pi times that radius squared times 12.5. So we'll come here. Let's do, hold on just a second. There we go. All right. So it was 1/3 pi times 0.923099 squared, 1/3 pi r squared times h. And our h, I forgot it was 12.5. And there we go. I got 11.15. It says round to the nearest tenth. So I'm a little bit nervous here, right? Because I did round this number and I got 11.15. The 5 makes the 1 become a 2. So if this doesn't come out to be right, I'm going to have to go back to my calculator and actually put in the correct numbers. So we'll see. We got 2 tries, right? So I got 11.2 centimeters cubed. See? And we got it right. Good. Okay. All right. So again, notice that they did not round like we did not round. Make sure you do that just to be safe with your answer. Okay. So this was the Delta Math version. Let me go to Edulastic and do a couple more word problems with you.